For this problem, we need to figure out the total distance of her hike. We know that she went from point A to point C to point B and then back to point A. To solve this problem, we need to figure out the sum of the distance between A and C and B and A. The distance between A and C is 3 miles. The distance between C and B is 4 miles. And the distance between B and A is 5 miles. Adding this up, we get 12. So the answer to this problem is 12 miles. For this problem, we need to figure out all the ways to go from point A to point B if she cannot walk over the same line more than once. Let's start by drawing out all the ways to go from point A to point B. As you can see, these are the only 4 ways to go from point A to point B, so the answer to this problem is 4 ways. For this problem, we need to figure out the shortest path from point A to point B. An example of the shortest path would look like this. As you can see, this path covers 3 sides and each side is 6 yards long, so we can do 3 times 6 to get the length of the path. 3 times 6 is equal to 18. So the answer to this problem is 18 yards. For part A of this problem, we have to figure out the shortest path between point A and point B. The shortest path would look something like this. As you can see, this path covers 4 sides, so we can do 4 times 9 to get the length, which is 36. So the answer to part A is 36 feet. Now let's do part B. For part B, we have to figure out the longest path. The longest path will look something like this. As you can see, this path covers 6 sides and each side is 9 feet, so we can do 6 times 9 to get the length of the longest path, which is 54. So the answer to part B is 54 feet. For this problem, we need to figure out the distance between point A and point E. We can do that by testing out different ways to go from point A to point E, and we see that ABE is the shortest way. So let's figure out the distance of ABE. The distance between A and B is 10, and the distance between B and E is 7. So we can do 10 plus 7, and we get 17. So the answer to this problem is 17 miles. For this problem, we need to figure out the longest distance from point A to point E. We can do that by testing out different ways to go from point A to point E, and we see that ABCDE is the longest way. So let's figure out the distance of ABCDE. The distance between A and B is 10 miles. B and C is 5 miles. C and D is 4 miles. And D and E is 8 miles. So adding this all up, we get 27. So the answer to this problem is 27 miles. For this problem, we need to figure out all the ways to go from point A to point E. Let's start by listing out all the ways that go through point B first. They would be ABE, ABDE, and ABCDE. Now let's list out all the ways that go through point C first. They would be ACDE, ACBE, ACDBE, and ACBDE. These are the only ways to go from point A to point E, so the answer to this problem is 7 ways. For this problem, we have to figure out the shortest distance that Maya can take. We know that she is leaving point A and wants to visit the points B, C, D, and E. We have to find the shortest distance, so we would travel to the closest point first. Since we are starting on A, the closest point to A is C, so we would go from A to C. The closest point to C is D, so we would go from C to D. The closest point to D is B, so we would go from D to B. And finally, we would go to point E. To figure out the distance, we have to find the sum of AC, which is 6, CD, which is 4, DB, which is also 4, and BE, which is 7. Adding this up, we get a sum of 21, so the answer to this problem is 21 miles. For this problem, we have to figure out how many distinct ways there are to go from the blue square to the green square. We know that we can only move right or down for each step. To go from the blue square to the green square, we have to move down twice and to the right twice. So basically, we have to figure out how many combinations there are to go down twice and to the right twice. They would be right, right, down, down, right, down, right, down, right, down, down, right, down, down, right, right, down, right, down, right, and finally, down, right, right, down. Since there are 6 distinct combinations, the answer to this problem is 6. For this problem, we need to figure out the distance between town A and C. We know that the distance between town A and D is 46, and the distance between town B and C is 16. We also know that the distance between town C and D is equal to half the distance between town B and C, so we have to divide 16 by 2 and we get 8. To find the distance between A and C, we can subtract the distance between C and D from the distance between A and D. So we would do 46 minus 8, and we get 38. So the answer to this problem is 38 miles. For this problem, we need to figure out all the ways to go from point A to point E if we follow the direction of the arrows. Let's start by listing out all the ways that go through point B first. They would be ABE, ABCE, and ABCDE. Now let's list out all the ways that go through point C first. They would be ACE and ACDE. These are the only 5 ways to go from point A to point E, so the answer to this problem is 5. For this problem, we need to figure out all the ways to go from point C to point E in the direction of the arrows. Let's go to point A first. Once we're at point A, we can only go to point B. Once we're at point B, we can only go to point E. So the only option that goes through point A first is C, A, B, E. Now let's go to point B first. Once we're at point B, we can only go to point E. So the only option that goes through point B first is C, B, E. Now let's go to point F first. At point F, there are 3 different options. Let's take the first option first. Once we're at point B, we can only go to point E. So the only option that goes through point F and point B is C, F, B, E. Now let's take the second option at F and go straight to E. So the only option that goes through F and E first is C, F, E. Now let's take the third option and go to D. Once we're at D, we can only go to E. So the only option that goes through F and D first is C, F, D, E. These are the only 5 options, so the answer to this problem is 5. For this problem, we are trying to find the perimeter of the pool. We know that when a youth walks from point A to point B to point C to point D, he covers a distance of 38 meters. So that means 2 times the length plus the width is equal to 38. We also know that when a youth walks from point B to point C to point D to point A, he covers a distance of 31 meters. So that means the length plus 2 times the width is equal to 31. We don't have to find exactly what the length or the width is equal to because we are trying to find the perimeter, which is equal to 2 times the length plus 2 times the width. To find the perimeter, we can start by finding the sum of these 2 equations. So adding 2 times length plus length, we get 3 times length. Adding width plus 2 times width, we get 3 times width. Adding 38 and 31, we get 69. To go from 3 length plus 3 width to 2 length plus 2 width, we can divide this equation by 3 and then multiply by 2. So dividing this equation by 3, we get length plus width is equal to 23. Multiplying this equation by 2, we get 2 length plus 2 width is equal to 46. Since we are trying to find 2 length plus 2 width, the answer to this problem is 46. For this problem, we have to figure out how many different ways the car can go from town A to town B. To go from this point to this point, there are 2 ways. To go from this point to this point, there are 3 ways. To go from this point to this point, there are 2 ways. To figure out how many ways there are to go from town A to town B, we have to multiply the number of ways to go from one point to another. So we would do 2 times 3 times 2, and we get 12. So the answer to this problem is 12 paths. For this problem, we have to figure out the average rate for the entire trip. To solve this problem, we can use the formula distance divided by time is equal to the rate. The distance between A and B is 120, B and C is 120, and C and A is also 120. So the total distance is equal to 3 times 120, which is 360. Now let's figure out the time. To figure out the time, we can use the formula distance divided by rate is equal to time. The distance between A and B is 120. The rate is 60. So that means it took 2 hours. The distance between B and C is also 120. The rate is 40. So that means it took 3 hours. The distance between C and A is 120. The rate is 24. So it took 5 hours. The total time can be found by adding 2, 3, and 5, which gives us 10 hours. Plugging in 10 and 360 for distance and time, we have 360 divided by 10 is equal to 36. So that means the average rate for the entire trip is 36 miles per hour. For this problem, we have to figure out how many different paths there are that go from A to B that go through point C. Let's figure out how many paths there are that go from A to C first. To go from A to C, we have to go north twice and east twice. To find the number of ways to go from A to C, we have to figure out the number of unique combinations of 2 N's and 2 E's. We can do that by finding the total number of combinations first, and then removing the repeated combinations. There are 4 sayings, so the total number of combinations is equal to 4 factorial. Since the N's and E's are identical to each other, we have to divide the total combinations by the number of ways the N's and E's can be arranged in order to remove the repeated combinations. 2 N's and 2 E's can be arranged in 2 factorial and 2 factorial ways respectively. So we have to divide 4 factorial by 2 factorial and 2 factorial. And this would give us 6. Now let's figure out how many ways there are to go from point C to point B. To go from point C to point B, we have to go north once and east twice. Since there are 3 sayings, the total number of combinations is 3 factorial. We have to divide 3 factorial by 2 factorial since E is repeated twice. And this would give us 3. To find the total number of paths, we have to multiply the number of ways from A to C by the number of ways from C to B. So that would be 6 times 3, which is equal to 18. So the answer to this problem is 18. For this problem, we have to figure out the number of ways Caitlin can take from home to school if she travels either east or south. To get from home to school, she has to travel south 3 times and east 5 times. To solve this problem, we have to figure out the number of unique combinations of 3 S's and 5 E's. We can do that by finding the number of total combinations first, and then removing the repeated combinations. There are 8 things, so the total number of combinations is equal to 8 factorial. Since the S's and E's are identical to each other, we have to divide the total number of combinations by the number of ways the S's and E's can be arranged in order to remove the repeated combinations. 3 S's and 5 E's can be arranged in 3 factorial and 5 factorial ways, respectively, so we have to divide 8 factorial by 3 factorial and 5 factorial. And this would give us 56. So the answer to this problem is 56 routes. For this problem, we have to figure out if the upper or lower path is shorter. Let's assume that the diameter of the smallest semicircle is equal to d. That means the diameter of this larger semicircle is equal to 4d, and the diameter of this semicircle is equal to 3d. The circumference of a semicircle is equal to the circumference of a circle, which is d pi, divided by 2, since a semicircle is half a circle. Let's figure out the length of this upper path first. We can plug in 4d into our equation, and we get 4d pi divided by 2 is equal to 2d pi. To figure out the length of the lower path, we can figure out the circumference of this semicircle was a diameter of 3d first. The circumference of that semicircle would be 3d pi divided by 2, which is equal to 1.5 d pi. Now let's figure out the circumference of this smaller semicircle. We can plug in d into our equation, and we get d pi divided by 2, which is equal to 0.5 d pi. The length of the lower path is equal to the sum of the two semicircles, so the length would be 1.5 d pi plus 0.5 d pi, which is equal to 2d pi. So that means the length of the upper path is equal to 2d pi, and the length of the lower path is also equal to 2d pi, so the answer to this problem is none, since the upper path and the lower path are the same length.